No, 2-dimethyl propanol.
Is it just 2-dimethyl? Check your note. Propanol
Oh
is
no,
correct.
2-dimethyl propanol.
Yeah, 2,2 hyphen dimethyl propanol, okay? And then if it's CH2, CH3, then it you should say the position of the branch, then the name of the branch, and then the whole long chain, name of the long chain, okay? Yeah, so now
What is CH2?
CH2, CH3. Now this whole thing, what is the what do we call it if it's a branch?
Oh, it's ethane.
Yeah, ethyl, okay? It ends with YL, and then this will be methyl. Okay, and now if I number it, it will be 1, 2, this second carbon and third carbon. So how to name it? 2
Mm,
ethyl, and then again you can say 2 methyl, okay? The position of the two
okay.
branches, and then propanol. But in between the number and alphabet, you just put hyphens. That's it. Okay, clear?
Yeah. Yeah.
And
Just could you give me 1 minute? I'll be right back.
okay. Reactions what alcohols undergo.
Uh,
Revise.
Alcohols can go through combustion and oxidation.
Combustion and oxidation, and then oxidation two types by
Yeah.
microbes, and then what was the other reagent here with the help of
Leaving it with potassium dichromate and dilute sulfuric acid.
in the presence of dilute sulfuric acid. Okay, why did we add dilute sulfuric acid here?
The dilute sulfuric acid
Yes.
to acidify the.
Okay, to acidify it, and then for this too, for potassium dichromate to act as an oxidizing agent, we add dilute sulfuric acid. Okay, check your note, you will have it. And then what color is chromate? Potassium dichromate or chromate ions?
They're orange.
Orange. Okay, so we have
They
Cr2O7.
and they go green.
Yeah, they go. Okay, so if I want to write the reaction, I can just write it with an alcohol. I'll just take it like this. Plus, we don't write the chromate one, no? We just put oxygen, and then that's 2 if we balance it. And I get what? It's a alcohol oxidized. What is the product?
Ethanol oxidized.
Yeah, when we when alcohol undergoes oxidation, what are the products? Can remember this is the
Uh,
equation, no?
oh yeah, you
The
get
reaction.
carbon. Is this complete or incomplete?
Complete. No, no, now this is oxidation, not combustion. Combustion is two types, complete and incomplete. Not that. I'm asking. Okay, we'll see this. What are the products? Now you said alcohol undergoes oxidation. So I add an alcohol with potassium dichromate, K2Cr2O7, which is green. in the presence of dilute sulfuric acid. Okay, we don't write this dilute sulfuric in the reaction. I'm just writing it. Now, what are the products? What we can get? You said it's orange. No, okay, sorry here. Orange, it turns to green. So why green?
Yeah.
Green confirms presence of what ions?
Uh, chromium ions.
Chromium. Okay, chromium 3 plus. And what else would be formed in the mixture? Alcohol. When it undergoes oxidation, what will form?
Alcohol. It makes a oic acid.
Yeah, so what's it? Carboxylic acid, right? If
Carboxylic
it is
acid.
like this, if I have an OH alcohol like this, if it undergoes oxidation, this whole thing changes. So it becomes C double bond OH, and then the rest we just write it the same way. Okay. So if this is two carbons, ethanol, then this is ethanoic acid. Okay.
Yeah.
Ah, now, so here we will have a carboxylic acid formed with water, and then the solution will turn green. So this confirms that chromium ions are formed because we know that the chromate ion Cr2O72 minus ions are orange. So when it is green, we know it has undergone reduction. Okay. So if this is oxidation, the other one should be reduction. And this type of reactions, we call it redox reaction because both take place at the same time. And if I want to write that in a reaction, like in a proper reaction, how do I write it? I just add that alcohol. I'll take ethanol here. Okay. So alcohol plus, we don't write K2Cr. For the oxidizing agent, we just put an O, right? It was in the textbook, and remember this reaction. And then it would
Yeah.
form C double bond O, OH plus what?
C double bond O H plus.
Check your note if you can't remember. Don't you have your note?
Yeah, I do.
Okay.
Oh, water, water.
Water. Okay. So what are the conditions for this reaction to take place?
It must be under reflex heat.
Yeah, we should heat it under reflux, and then that is using a reflux condenser. So, and then we ethanol, potassium dichromate in dilute sulfuric acid is the starting material there. The observation what we can see is orange turning into green because chromate ions are green, and then because of the presence of chromium ions or formation of chromium ions, it will be green. Okay, what is the oxidizing agent in this reaction? Which should undergo.
Oxidizing agent is the one that's being reduced.
Okay, so who
So,
was reduced here?
oxygen.
Okay, we got oxygen from potassium dichromate. Okay, K2Cr2. So without writing this complex thing, we are just writing it as oxygen. Clear? So in this reaction,
Yeah.
what we do is we take a boiling tube, we add in potassium dichromate, and then the orange color solution, and then we add alcohol. We heat it under reflux, or we can also use a round bottom flask for this, like the diagram given in the textbook. The products would be all these. Okay. So the oxidizing agent here is potassium dichromate. Without giving you that complex reaction, they have given you this reaction. So you can't write that the oxidizing agent is oxygen. Okay.
Yeah.
Yeah.
Okay.
Uh, and then can you tell me two ways? Okay. So oxidation can also happen with the help of microbes. What are the conditions there? And what is the most common microbe? Microorganisms like what?
Yeast.
Oxidize alcohol. Okay, yeast. And what are the conditions?
Uh, it will have to be in 30
Okay, 30 degrees
uh,
Celsius. The
for
30 to
gentle
40. Okay.
fermentation.
The
Yeah.
process is called fermentation, right?
Yeah.
And then it should,
Gentle fermentation.
and anaerobic, it's anaerobic respiration. So it should be in the absence of air and oxygen. Because what will happen if this yeast and the alcohol reacts in the presence of air?
Alcohol and yeast.
Yes, alcohol and yeast, if it
They
reacts in the
go
presence
through
of,
an aerobic respiration.
yeah, so it will produce carbon dioxide and water. We don't need these products, right? So we need alcohol, right? Ah, not alcohol, oxidation, the ethanoic acid. So what will this produce? Alcohol and yeast. Tell me, in the absence of oxygen or under anaerobic conditions, what will they produce? The enzymes in the yeast will oxidize the alcohol. So again, I will have a carboxylic acid. Okay. So
Yeah.
this is one way of producing carboxylic acid. And who provides the enzymes for this reaction to happen? Enzymes are present in the yeast. Okay, that is why we add yeast. And then why should we do this experiment or like have the temperature at 30 to 40 degrees Celsius? Because it is the reaction is controlled by enzymes, right? So there should be some optimum temperature for it to function. If it's too high, it can denature. Even if it's too low, the rate of reaction can be too low. Okay. So making ethanol by fermentation. Okay, I have written the reaction wrong, no dear. What is the fermentation reaction? Tell me. It can't be ethanol. That is oxidation with the help. This is oxidation with the help of microbes. That is
So it's
microbes.
what's it called?
Again, this is correct. This reaction is correct. That is oxidation by microbes. Okay, so ethanol will in under anaerobic condition, like microbes like yeast, will produce carboxylic acid. But mm, okay, so tell me, for fermentation, what is the reaction? Yeast is added to what?
Yeast is added to the alcohol.
No, no, no. Fermentation is producing alcohol. So how can yeast be added to alcohol?
I'm not sure what you mean.
Okay, now,
Like,
okay, these are the two types of reactions of alcohol. Okay, alcohols with OH group. So when we look at the reactions, you said we have combustion and oxidation. Combustion is where we have the complete combustion and incomplete combustion. Are you okay with that? Like
yeah,
any alcohol with oxygen will produce carbon dioxide and water. If it's incomplete combustion, it will be carbon monoxide and water, or else carbon and water. That's soot and water. Okay. Now, if it
yeah,
is oxidation, again, two types. We have with in the presence of microbes and in the presence of an oxidizing agent like K2Cr2O7 in the with dilute HCl. So the microbe reaction here is, it should be an alcohol, right? So alcohol, when it reacts with microbes like yeast, it will oxidize and become a carboxylic acid. Clear?
yeah.
This is oxidation. So now that's done. Okay, tell me, how can we produce alcohol? Now this is a different chapter. I'm asking how methods to make alcohol.
Uh, there is the industrial version where they heat it up at 300 degrees.
That's hydration, no?
Yeah, hydration.
Hydration of what? Ethene, right? Any double bonded.
Ethane.
So if I have something like this and I add it with water, then with the conditions like 300 degrees Celsius and 60 to 70 pressure, and what is the catalyst here? Catalyst used in hydration,
The catalyst used was the phosphoric acid.
phosphoric acid. So that will produce alcohol. So this is one way in producing alcohol. Okay, so we will have an alcohol here. That if this is ethene, it will be ethanol. Okay, now can you tell me another way in make production of alcohol? That is fermentation. Okay, so that is, we should produce alcohol. So in the product side, we will have alcohol. We react what with yeast or the microbes.
With yeast, um, bacteria,
Okay, yeast is a bacteria.
oxygen.
Oh, no, no, no. It happens in anaerobic condition.
Uh,
Okay, now what do we react it with? We react it with sugar, glucose, okay? So glucose
Okay.
and yeast, in the like microbes like yeast and in the anaerobic condition will produce glucose and ethanol and carbon dioxide. Okay, so that is fermentation. This is another way of producing alcohol. Okay, these two reactions are different. See here, this reaction is different. Like this is oxidation of alcohol giving and a carboxylic acid. Okay, here it's fermentation. This is a method in which alcohol can be produced. Fermentation. Two different things, but again it's the same microbes. The substrates are different. Here it's alcohol with yeast. Here we react glucose in the presence of yeast and anaerobic condition and all that, giving us alcohol and carbon dioxide. Here it's carboxylic acid. See, two different reactions. Okay, let me just go into the note. See the fermentation. Yeast is added to sugar and then left it for like several days at 30 to 40 degrees Celsius. Yeast will convert the sugar into ethanol and CO2. This is called fermentation. The temperature is because the enzymes is the one which enzymes are produced by the yeast. So because too high temperature can denature the proteins, we have to have the optimum temperature like 30 to 40. Okay, this is the reaction. Glucose to it converts to ethanol and carbon dioxide when we mix it with yeast in the absence of oxygen. Clear? So the starting
Yeah.
material, glucose, temperature, catalyst. See, the catalyst is enzymes in the yeast here. This is fermentation is different. Oxidation of alcohol by microbes is different. So this is oxidation of alcohols by microbes. If you see, ethanol will convert to ethanoic acid. Again, the same thing. But here, ethanol is oxidized with the help of microorganisms, again by bacteria or yeast. It converts to this. The reactants and the products are different in both the reactions. Okay,
Yeah.
don't get confused. And then we have some advantages and disadvantages, the differences between hydration of ethene and then the fermentation process. You should know that. I think we did question 2, no? That was done, and question 3 was also done.
Yeah.
Okay, now with the topic carboxylic acids. So carboxylic acids are organic compounds which contain the functional group C double bond OH, C double OH. So you write it like this, C the double bond O and just OH together. When it was alcohol we wrote it separately, right? O separately and H separately, and we showed the bond in between. But here no need to show the bond in between O and H, okay? You can just draw it. An example of this again, when it comes to carboxylic acids, listen. So when it comes to carboxylic acid, the same way. The name ends with oic, just like alcohols end with methanol, propanol, all, and then alkanes ended with ane, alkenes ended with ene, right? So the same thing, carboxylic acids end with oic acid. So if it's one carbon, it's methanoic acid. Two carbons, ethanoic acid. Three, meth proprite, because it's a carboxylic acid functional group, propanoic acid. The same way, butanoic acid. And they have given you the molecule and the structural formula. Are you clear with all this?
Yeah.
Okay, the most common the ethanoic acid is the first one, ethanoic acid. Eth is two carbon, right? So two carbon containing carboxylic acid like this. I hope you're listening. So the
Yeah.
common name is acetic acid or vinegar. The vinegar what we use, that is an carboxylic acid, okay? It is acetic acid or it's an ethanoic. It is ethanoic acid. That is the chemical formula. So how are carboxylic acid formed? Can you tell me? We learned it. So by when can we form carboxylic acid? When alcohol is oxidized, right? When I
Yeah.
have alcohol and then I have to oxidize it with the help of, it can be with the help of microbes or oxidizing agents like potassium dichromate. Then I will have an uh, carboxylic acid formed, okay? Clear?
Yeah.
And then again, just like the word says, it is acid. So all the reactions of carboxylic acids will be same like the acid reactions. Now, if I just say magnesium plus HCl, you know HCl is an acid. So what will be the products? So metal and an acid, what will
Um,
be the products?
it will be MgCl2 and H plus H2.
H2, okay. So metal and an acid will give the salt and hydrogen gas, right? If it's a metal, if it's an acid and a base, what will it give? Acid and a base.
Neutralization, so salt and water.
Salt and water. If I just take HCl plus NaOH for a base, then it's going to be its respective salt and water. If it's a metal and an acid, it's going to be salt and hydrogen gas. The same carboxylic acids, because they are also acids. Well, who are acids? Can you tell me the definition for acids?
Acids are compounds that have hydrogen, and they are they have a pH level of uh, 2.
Is it only two?
No, from 7 to 2, 7 to 1.
0 to 6. Okay, 7 is neutral. 0 to 6.
Ah,
0 to
0 to
14,
6.
7 is neutral. After 7, it's basic. The basicity increases. Here, the acidity
Yeah,
increases downwards. Okay. If I just take pH 2 and pH 5, who is more acidic?
pH 2.
pH 2 is more acidic. Okay. So, carboxylic acids. Okay. Acids are not substances which contain hydrogen. Now, H2O also contain hydrogen. That doesn't make it an acid. Okay. Any solution or like any substance which, okay, just take it as like this.
Or
Any
can
substance.
totally dissociate, like
Yeah.
it can
Dissociate what?
dissociate the hydrogen.
Hydrogen ions in water. Okay, when we put it in
Yeah,
water, if it dissociates or if it releases hydrogen ions in water, then it is an acid. Okay.
yeah,
If it is just going to hold it like hydrogen gas, no, it's not an acid. If I just put it in water or dissolve it in water, it's still going to have the electrons. The H1 go as H plus and another H plus. They'll still be like, they can still be like this. Understood? So acids
yeah,
are the substances which release H plus ions in aqueous medium. Alkalis are substances which release hydroxide ions in aqueous medium. Okay.
yeah,
Ah, so carboxylic acids, they are weak acids. Again, still they are going to release H plus in the ion, H plus in aqueous medium. Okay. Now, if I take HCl, can you tell me how it dissociates? HCl is an acid. So how does it dissociate? HCl aqueous.
it turns into OH minus and Cl2.
There is no OH here. No. No, no, no. What are the ions present in HCl?
H plus and Cl minus.
H plus and Cl minus. This is how you should write if they ask you the dissociation reaction for this acid, okay? And if it's HNO3, how do I write it?
It will be H plus and NO3 minus.
NO3 minus, okay? If it's H2SO4,
This will be H plus and then SO4 2 minus.
2 minus. Sulfate goes as 2 minus and it's 2H plus because 2 hydrogens here. Okay, if it's NaOH, if it's an alkali, aqueous,
It will be Na plus and
and
OH
OH
minus.
minus. Okay, now the same way, this is also still an acid. So if I just write CH3COOH, it's a carboxylic acid. This is 2 carbons, so methanoic acid. Okay. Sorry, ethanoic acid. Okay, clear?
Yeah,
Now, if it's
yeah,
ethanoic acid, how do I write the dissociation? The negative ion goes like CH3COO minus, and you write the other one CH3COO minus plus H plus. Clear? This is how we write it. Whenever it's carboxylic acid, this whole thing, the first one, the first whole set gets the minus sign. Okay? We call it the ethanoate ion. Just like H plus is hydrogen ion, SO4 2 minus is sulfate ion, Cr2O7 2 minus is chromate ions, Cr3 plus is chromium ions. Now we are learning a new ion, CH3COO minus. It is ethanoate ions. Okay, by one carbon, and then it goes like ethanoate. Okay, clear?
yeah,
Got an I like understood this. This is how it dissociates. Now it's an acid, right? Now we are learning the dissociation reaction for a new acid. Okay.
yeah,
So if it's ethanoic acid, this is how it dissociates. Now we know HCl dissociates like this. HCl goes as H plus and Cl minus. Always we go give this, right? The hydrogen ions and all the others minus. The same way, if it's a carboxylic acid, the name says acid, so it should dissociate. How? This whole thing, the first one goes as the minus. So CH3, COO minus plus H plus. Or in other way, I just can write the other way around too. H plus plus. All the others, I just put it together and I then put a minus. So this ion is called ethanoate ions. Just a name for that ion. Okay?
Yeah.
Okay, now write the first point. Carboxylic acids contain the functional group COOH. I'll ask you to send pics, okay? So write it clearly. So carboxylic acids contain the functional group COH, and I want you to draw this.
So what do I write down? The
This whatever is underlined. Carboxylic acids contain the functional group COOH, and I want you to draw this.
okay, I'm done.
And just write it as examples, and you can write ethanoic acid and propanoic acid, and with the name, okay, the structural formula and the name. If it's one carbon, it's meth, okay? It's the same. It ends with oic. Okay, are you done?
No, Do I have to also do the structural formula and molecular formula?
No, just only the name and the displayed structure formula is enough. This is called the condensed structural formula, right? If you want, you can take it
Yeah.
down.
Okay, I'm done.
Okay, right. Exam. Oh, put a star mark and write ethanoic acid is vinegar. It is also called acetic acid. Know that. And then put the subtopic production of carboxylic acids. So how do we produce carboxylic acids?
By oxidation or combustion.
How can combustion give carboxylic acid? Combustion
Oh,
gives
so
only
it's only
carbon.
hydration. It's only hydration.
Hydration gives alcohols, no dear.
So it's only made from oxidation.
Yeah, oxidation, okay? Oxidation of alcohols with microbes or potassium dichromate in dilute sulfuric acid. So I'm not giving this again reaction in detail, but you should know, okay? And then if you want, you can just take it down. CC.
Okay, miss, I'm done.
Okay, now put the subtopic acid properties of carboxylic acids. So carboxylic acids are weak acids. We'll write it down. Now they turn blue litmus paper red because they are still acids, okay? Now this can be used as a test also to identify carboxylic acids. And then dissociation of carboxylic acids. You can just write, we'll just write one example. So if it's CH3COOH, what is the name of this acid?
That is 2, so it's ethanoic acid.
Yeah, ethanoic acid. And then what will it dissociate to? The negative ion is CH3COO minus, okay? Plus H plus. And what is this
Yeah.
ion? Ethanoate. Ethanoate ion, and this is hydrogen ion. So if it's another example, I'll just take. Okay, wait, let me check that. Okay, done.
No. What's the state symbols?
It will be aqueous because acids
All
release
of them?
hydrogen ions only in aqueous medium now. Yeah.
Okay, I'm done.
So next put the topic reactions of carboxylic acids. So again they show the same reaction just like acids, okay, normal acids like metal plus acid and a base likewise. So the first type will be so first will be reaction with metals and reaction with carbonates. Now tell me what will happen when an acid reacts with a carbonate. HCl plus copper carbonate. What are the products?
You get is that copper carbonate? You get
Yes.
copper chloride and uh, is it the C double O H?
No, dear. Copper carbonate. The COOH is.
Yeah.
Wait.
So H2O, H2O.
Carbonate and acid. Okay, I have written it the other way. I think you're confused for that. CuCO3 plus HCl. Or just think of calcium carbonate plus HCl. What will it form? CaCl2 calcium chloride plus.
Uh, calcium chloride. Mm, CO3.
Carbon
I'm
dioxide
not
plus
sure.
water, no?
Carbon dioxide plus well. Okay.
Carbonates, they decompose to have carbon dioxide and water. Always, whenever carbonates are present, it's carbon dioxide and water, right?
Yeah.
Okay. So acids, these were the three types of reactions. Metal and an acid will form salt and water. Sorry, salt and hydrogen. Acid and a base will form salt and water. Acid and a carbonate will form salt, carbon dioxide and water. Okay.
Yeah.
We learned all this and in the reactivity series. Okay, so reaction of carbonates, it's the same thing. Here again, these acids are going to react with any, it can react with any metal, sorry, or any carbonate. Now put the subtopic reaction of carboxylic acids with metals. So example, we'll just go with magnesium solid plus ethanoic acid, CH3COOH. Now this is the acid here, right? And this is the metal. Clear?
Yeah.
Okay, now what will be the products? It should form salt and hydrogen. So tell me what will be the salt and what hydrogen. I can just write it, okay? Now for the salt,
Magnesium. Uh,
okay, it goes like this, okay? CH3COO and then magnesium. Okay, now if I just write the chemical formula, it's CH3COO. This is 2 and this is 1, right? So this should get 2. Got it?
Yeah.
So we put a bracket and write it. Now, normally in all other acids, we write the positive ions first, the metal first, and the negative ion comes next. But here, the negative, we write the negative ion first and the metal next. Okay, that's different here. Understood? But writing the chemical formula is the same. Here, you know why you got a 2 here. Okay, clear? Plus
Yeah.
hydrogen gas.
Did
Now,
I
what
write
are,
this down?
yeah, write it down. So, what do you think will be the observation here? A gas is formed, so what should be the observation?
Hydrogen is created.
That can't be observation.
Fizzing,
Okay,
fizzing, fizzing,
fizzing.
fizzing.
Okay, yeah, and then okay, what is this? So here, this compound we call it magnesium. What is the other ion? Just like magnesium chloride. Now this is magnesium. What is this ion? CH3C double O minus. Tell me. So if the salt is MgCl2, we call it magnesium chloride, right? Or this is magnesium sulfate because this is sulfate ion, this is chloride ions. Now I'm asking what is the name, what can be the name of this compound? Magnesium CH3 double O minus. What do I call it? I gave you. Check the note.
It was
Ethanoate. Okay.
ethanoate.
So it is
Ethanoate.
magnesium ethanoate. Clear? The
Yeah.
product is magnesium ethanoate and hydrogen. Now, do you think we can add zinc and acid to this? Sorry, sodium and acid. Sodium reacts, now if you can remember the reactivity C
Vigorously.
vigorously, even with cold water. So do we add it with dilute acids?
No.
No, we don't do it. But again, if we do it, it will be the same products, okay?
Miss, is it two of that ethanoate?
Yes. You know why we got this two, no? If you want, you can
Oh,
just
it's
write it.
-1 valency.
Yeah, CH3C double O. This is 2. Magnesium is from group 2, so the valence is 2. Here it's 1 because it's -1. When we cross it, it goes as magnesium CH3C double O brackets 2. Now, when we write ethanoate salts, the carboxylic acid salts, we write the negative one first. Okay, and then comes the metal. Clear?
Yeah. Okay, miss, I'm done.
Okay. Now, can you write it for zinc and ethanoic acid? Metal is always solid. Unless, yeah. And then you can write the name of the product also.
Miss zinc is 2 plus, right?
Yeah.
Okay, I'm done.
Can you send me a note? All the notes from
Everything?
carboxylic acid, yes. Okay, now why did you write the metal first? Zinc should come the other side. When we are writing salts of carboxylic acids, it goes like this. Okay, and then see zinc, CH3, double O. This is 2, this is 1. So this whole thing should get a 2, no? Like you have just put the bracket without the number. Understood?
Yeah.
So it's zinc ethanoate, and the name is zinc ethanoate. Write it. Change it. Change the whole thing, or like cut it and write it again. Okay, shall we move to the
Okay.
next? Understood up
Yeah.
to this? Memorize these
Yeah.
terms, these small terms, this because this is the first time we are learning, but it's easy, okay? If you just go through, it's the same thing.
Okay.
Just a new ion. You would have learned H plus is hydrogen ions, SO42 minus is sulfate ions. Now you should just know that CH3COO minus is called ethanoate ion. Okay?
Yeah.
Okay, now new topic, reaction of carboxylic acids with carbonates. So we'll just first write the general equation. So acids plus carbonates will give salt, CO2 plus water. Okay. Okay, now we'll just go with. Okay, can you write the reaction between sodium carbonate and ethanoic acid? Not the word equation. If you want, you can just fill that too and write the chemical equation. Okay. Write it with the physical state, the name of the compound, and all that.
So it would be carbon dioxide, water, and hydrogen, and sodium ethanoate.
It should be sodium, ethanol, carbon dioxide, and water. Do we have hydrogen here?
Wouldn't the ethanoic acid produce hydrogen?
Yeah, but that goes with that hydrogen is water here. Okay. Not hydrogen won't be released. Hydrogen is released when a metal reacts with acid. Okay. Take it down. Write down the chemical formula. You can send your answer. Write it with the physical state and then make sure write the chemical formula of sodium ethanoate clearly. Write it. You can also show the working down. Okay, even for magnesium ethanoate and zinc ethanoate, just take the working down in this piece. There. Done.
Um, no, not yet.
We should be done by now.
Yeah, 1 second. I wrote the word equation. I'll quickly turn it into the chemical. Miss, carbonate has a valency of 1.
Carbonate is 2. So I've sent a question set on alcohols. Have a printout of that on Friday, okay? Not the
Yeah.
Tuesday, not tomorrow. You can have it for the Friday's class.
Okay, I'm done.
Yeah, send me. You can also try between ethanoic acid and calcium carbonate. Yeah, send your answer. Sodium carbonate, ethanoic. Okay, what's your mistake in writing the salt? What should come first? The negative part should come first and then the metal, no? Not sodium. The sodium should come. Now, if it's Na2CO3, did you write it as Na2? Yeah. And then CH3COOH. So we will have it between carbonate and CH3COOH, COO minus, and sodium plus. So 1 and 1. But you should write CH3COO and Na. Do you get it? First. Normally, we don't write the metal first when it comes to carboxylic acid salts, okay? Like the zinc, you wrote it next second, no? And then again you wrote magnesium also the after the negative ion. Remember? And then it goes as carbon dioxide plus water. Just a small difference when writing the chemical formula of this salt. Highlight it if you have a highlighter. Change it. Did you get the point? Understood?
Yeah.
Okay, so highlight those compounds then. So see the magnesium came at the end, zinc at the end. So same way we should write the metal next to the negative ion, not like in other compounds. See, magnesium was second there. Here we put zinc here. So the same way sodium should come after this. Okay.
Yeah.
Okay, now can you do it for the other example? Calcium carbonate and ethanoic acid. And you can write the physical state. Sodium carbonate, solid, aqueous, again aqueous, liquid and gas. So ethanoic acid, CH3COOH plus calcium carbonate, both have a valency of 2. Calcium, CH3COOH minus, right? So 2 and 1, you cross it. Write the products.
Okay, I'm done.
So did you write it as CH3COO and calcium and 2 here like this?
Yeah.
Okay, so this is solid, calcium carbonate solid. This is aqueous. Again, this salt formed would be aqueous. Carbon dioxide is a gas, water liquid. Okay, clear?
Yeah.
Okay, so what do we call this salt?
Um, insoluble? No.
No, dear, the name of the compound.
Oh, that. Oh, calcium ethanoate.
Calcium ethanate. Okay, if you want, you can just write it down. So that's about carboxylic acids. We are done with that part. That lesson is done. Do you have any questions?
No.
Okay, you should know the functional group, naming and labeling it, and then the reaction. So the same reactions like how acids react, but only the ion is different. Okay, the ethanoate ion, and the metal should come front. Can you do question 3?
Yeah.
I'll give you like 10 minutes. Make it fast. Okay, I'll be back. Okay, do the question.